So if you search like CCIE Enterprise Infrastructure Lab Exam, you will get this link here from Cisco itself. So CCIE Enterprise Infrastructure exam topics, just click on this link. And here they have given like all the topics that you should know before you can attempt the Enterprise Infrastructure Lab exam. The current version is 1.1. Also note that Cisco, they keep changing the content, they keep updating the content, so make sure that you are practicing for the latest version, that is in our case 1.1. For other tracks such as SD-WAN, the routing NRC and the other tracks, make sure that you are referring to the official content from the latest exam. So the latest exam for the CCIE Enterprise Infrastructure is actually 1.1. At the moment, there are no changes planned for the CCIE Enterprise Infrastructure. So this will remain there at least for next 1 year, and I can confirm it because if I go to this, there is a link from where you can track actually what are the changes expected in the content, when are the changes expected in the content. So this is one of the link that you should take a look on. I have sent the link in the chat, by the way. Both of the links I have sent in the chat. You can click on the link and bookmark it. Keep it with you, and just keep looking at this Cisco certification roadmap. This link will provide you the information like when the changes are going to happen. For example, if you scroll down, our enterprise infrastructure, the enterprise right here, the enterprise in the Q2, if the changes has to be done like in the Q2 of the year, Cisco is going to review or analyze the job tasks. In Q3, they will publish the new blueprint, and in the Q4, the updated exam will go live as per our enterprise track. And what is this Q2? Q2 is basically November to January. What is this Q3? Q3 is February to April, and Q4 is basically May to July. So understand that at the moment, here, since we are already on month July, and we have not received any updated information, meaning to say that at least for this year, at least for upcoming 6 to 8 months, the content will remain exactly the same. The content will be exactly the same. So if some changes are there, then those changes you can take a look at from here. For example, like Encore is on 1.1, NRC is on 1.1, SD-WAN is on 1.2, by the way. Some design, wireless design, so enterprise automation is on version 2.0. So, and our enterprise infrastructure lab exam is on 1.1. So just always keep an eye on this this document, this link, where you will get to know like when the changes are planned, and based on that you can start preparing for the exam as well, just in case if you are planning for exam anytime soon. So we'll be talking about this enterprise infrastructure version 1.1 lab exam. Also, we will cover the encore, all the routing related topics from encore will also be covered here in our content. So if I click on this exam topics here, the encore exam topics, and this is CCIE Enterprise Infrastructure Lab exam topics. So encore is more like, by the way, encore is more like the written exam for the Enterprise Infrastructure Lab exam. So you have to pass the encore exam, then only you can attempt the lab exam. So the topics that we are going to cover in our Enterprise Infrastructure Lab exam, this one will almost cover all the routing topics from the encore exam as well. So you will not need like any dedicated classes from the encore content point of view. Again, since it's a routing classes, I am talking about routing only. I am not talking about other stuff such as like wireless. I am not talking about like the security. I'm not talking about the SD-WAN, SDA. I am just purely talking from the routing point of view. So what things we are going to cover, by the way? So CCIE Enterprise Infrastructure Practical Exam Lab Exam. So if you just scroll down, here are the list of topics. You can download it, by the way, in the PDF format. You can download it, keep it with you, and make sure that all the topics from this content is covered. So this is what we are going to discuss. This is what we are going to cover in our CCIE Enterprise Infrastructure routing content. So the CCIE lab exam is divided into total 5 parts: network infrastructure 30%, software defined infrastructure 25%, transport technology and solution 15%, infrastructure security and services approximately 15%, infrastructure automation and programmability 15%. So if I expand it, if I click on it, if I expand it, it will give me the detailed information. It will give me the detailed information about the topics that we are going to cover. So the first point is basically switch campus. It is from the switching point of view. So whenever you go for the switching classes, all these topics from the switching, like switch administration, layer 2 protocol, VLAN technology, ether channel, spanning tree, all these topics are covered when you cover the switching part. Since it's a routing classes, we will not be talking about this particular content. This is covered specifically in the switching. What we will talk about is the routing concepts. So under the routing concepts, we have the AD value, administrative distance. Then we have static routing for unicast and multicast address families. Then we have policy-based routing, VRF, VRF Lite, VRF aware routing, route linking between the VRF using route maps and VASI, VRF aware software infrastructure, just a technique in the iOS XE devices to perform the inter-VRF communication. We'll talk about it later on. Route filtering using BGP, EIGRP, OSPF, redistribution, routing protocol authentication, BFD, layer 3 MTU. So under the 1.2, the basic routing concepts, the concepts related to the basic routing, we will talk about, like the AD and all that stuff. Again, it also to let you know that it's not going to be covered in the exact same sequence. We will keep discussing the content, and throughout the content, these topics will be covered anyway. So it's not like we are going to talk about in the exact same sequence. So we will start the content, we will continue with the content, and these topics will be covered. These topics will be covered like throughout the content. So basically, introduction to routing and the routing concepts we will talk about, and then we will talk about the routing protocol. Here also we'll talk about like static routing, IPv4, IPv6 routing and all. We will talk about that. And then we'll talk about the EIGRP, EIGRP adjacencies, best path selection, EIGRP operation, EIGRP named mode, convergence, optimization, scalability, all these EIGRP for IPv4 and IPv6 related topics we will cover under here. This will cover EIGRP for both IPv4 and IPv6. Then OSPF version 2, version 3, again OSPF for IPv4 and IPv6. So OSPF version 2 was designed for IPv4 address family, IPv4 addresses basically, and OSPF version 3 is specifically designed for IPv6. However, it does support both IPv4 and IPv6. So we'll talk about OSPF for IPv4 and IPv6. So adjacencies, address family, network types, path preference, general OSPF operation, the LSAs, the path manipulation and all that thing. So these we will cover under the OSPF. OSPF for IPv4 and IPv6. And then you already know the border gateway protocol, the BGP, IBGP, EBGP, peer group, templates, active, state, passive, state, timers, dynamic neighbors and all that. Basic IGP, IBGP, EBGP concept. Then BGP best path selection and manipulation, routing policies, outbound out filtering, conditional advertisement, communities, multi-homing scenarios, different routing policies related to border gateway protocol. Then the AS path manipulation, how the AS path can be manipulated, AS migration, AS path prependation, local AS and all that additional concepts that we will talk about. And then in a large scale BGP deployment, using route reflector, using configuration, using full mesh BGP neighborship and all. So convergence and scalability from the BGP point of view. Other BGP features such as software configuration, route reflector. So these are the topics that we will focus on. We'll talk about a few more things, but these are at least the topics that we should know from the content point of view. So these are the bare minimum things that we will cover. Apart from that, some other additional small commands, small topics we will cover under the border gateway protocol for both IPv4 and IPv6. And then once the unicast routing is done, then we will move on to the multicast routing. In the multicast routing, we will talk about like how can we perform one-to-a-group communication. What is this layer 2 multicast? What is this IGMP snooping, MLD? MLD is basically for IPv6. So what is this layer 2 multicast? What is this like PIM, sparse mode, dense mode, sparse dense mode, a source specific multicast, anycast, RP, MSDP, whatever concepts are there regarding the multicast, we will talk about as a part of our So this will be pure routing. This will be like pure routing for both IPv4 and IPv6 address families. So this will be like from 1.2 all the way to this 1.6. This is going to be pure routing content for unicast, for multicast. Also, I'm not going to say that it's going to be everything. Like it's not like once we cover the BGP from our CCIE content point of view, it's like it's complete BGP. It's not like that. There will be like a lot of topics that we do not cover in the enterprise infrastructure, topics that are specifically there in the service provider tracks or in some other certification tracks. So we will keep our focus specifically on the topics that are listed here. Apart from that, a few things here and there, but we will not go beyond the content. We will talk only about the things, specifically about the things that are there in our curriculum. Specifically about all these topics that are here. I'm not saying that, I'm not going to say that we are going to cover the complete OSPF. We are going to cover the OSPF only from our content point of view. Apart from that, a lot of other things might be there, which we are not going to talk. Maybe most probably you will cover those things in some other certification tracks such as service provider. These are the topics that you should know from the exam point of view. All these things that are there here, in fact, all those things that are there in the encore exam as well, regarding routing, by the way, all those things there are like completely like overlapping topics. So whatever things are there in the encore exam from the routing point of view, they are there in the lab exam also. So we will cover all those topics. We will not go beyond. Like we will not talk about additional things in the BGP, additional things in the OSPF, additional things in the EIGRP. We will talk specifically about the topics that are there in the content for both unicast and multicast address families, for both like EIGRP, OSPF and BGP, and in case of multicast, we'll talk about IGMP and the protocol independent multicast. Whatever things are there in the content will be covered completely. Apart from that, like additional things that are part of some other certification exams, we will, of course, not talk about them in our enterprise content, right? So this is one of the part that we will cover. So switching we will not cover. Switching is a part of like a dedicated discussion. So switching we will not cover. We'll start from the routing fundamentals, and then we will cover all the things all the way up to the multicast. This is going to be approximately 30% of the entire content. So 30% divided by 6. So there are 6 units. There are 6 topics basically, and there is like 30% weightage for this particular topic. So 30 divided by 6. Each and every section is approximately like 5%. So so these network infrastructure, under the network infrastructure, we'll talk purely about the routing. Then we will not talk about the software-defined networking, SD-WAN, SDA. This is again a dedicated content, the software-defined access and the software-defined WAN. So this is not part of our routing discussion. So we are not going to talk about the software-defined networking, software-defined infrastructure. This 25% curriculum is covered in a dedicated class for like dedicated class of SD-WAN and SDA. So we are not going to talk about SDA or SD-WAN. So you can skip it. Then we will talk about the transport technology and solutions. Transport technology and solutions. Here we will talk about the tunnels. Here we'll talk about the static and point-to-point GRE tunnels. We'll talk about MGRE. We will talk about DMVPN. We will talk about IPsec. And we will talk about the MPLS technology and MPLS-based VPN services, focusing specifically on the topics that are mentioned here. VPN is a very big topic, by the way. There is in fact a dedicated exam in the security called SVPN. There is a dedicated exam in the security track called SVPN. So VPN is a very big topic. Same goes for like MPLS. MPLS you will see mostly in a service provider environment where they will talk about things such as traffic engineering and other basically concepts. L2 VPN, L3 VPN in quite detail. We will keep our focus only on the topics that are there in the certification exam. So we'll talk about the static, like we'll talk about the GRE tunnels, we'll talk about the point-to-point GRE, we will talk about the DMVPN, and by the way, we will also talk about the IPsec. We'll talk about the IP security, we'll talk about the IPsec, but we will talk about only the things that are there in the content. We will not talk about like anything beyond our content, such as, for example, in IPsec, it says that we must know how to configure the IPsec using pre-share key. So we'll only talk about the pre-share key. We'll not talk about those certificates. We'll not talk about those digital certificates or certificate-based authentication process. We will not talk. Same the DMVPN. You can see that the DMVPN phase 3 with dual hub. So we will talk about like single hub DMVPN, dual hub DMVPN, how to secure the DMVPN with this IPsec. We'll talk about all that, but there are some additional topics, some advanced topics of the DMVPN we might not talk about, such as when it comes to dual hub DMVPN, the redundancy, like active standby and all those things. I will provide you the documentation, but since it's not part of our content, we will be not discussing about that point. Same goes for MPLS. You can see the content regarding the MPLS is very limited. We'll talk about the MPLS operation. We'll talk about how the MPLS works in a routed environment, how the MPLS-based packet forwarding happens, what is this MPLS ping and trace. Then we will focus specifically on the layer 3 VPN. We will focus specifically on the layer 3 VPN. We will not talk about actually the layer 2 VPN. We will not talk about the layer 2 VPN, how to build the layer 2 VPN services. But again, if some time is left, we will definitely see a basic configuration of any transport over MPLS, which is a layer 2 MPLS-based VPN service. And we'll talk about a few additional things, but we will keep our focus specifically on these topics. Our content focus is specifically the layer 3 VPN. As per our content, we don't need to worry about the layer 2 VPN or traffic engineering. Those kind of things we don't need to worry about. But in general, we will talk about the layer 2 VPN. We'll talk about some additional things in the MPLS-based VPN, but we'll keep our focus specifically on these topics. It's very limited, by the way. This VPN topic is very limited. They don't want you to know like all the things regarding the VPN in our enterprise infrastructure. They just want you to know the technologies more commonly used in the enterprise environment in order to enable the VPN services, DMVPN, IPsec, and all that thing. So we will definitely talk about all those. Once this topic is done, once the VPN topic is done, then we will talk about like the infrastructure security and services. In the infrastructure security and services, we will start with the content of the quality of service. We'll talk about QoS. We'll talk about the quality of service. Once the QoS topic is done, then we will focus on all the additional topics, small topics such as SNMP, syslog, router security features, IPv6 infrastructure security features. Then we'll talk about like the NTP. We will talk about the precision time protocol. Then we'll talk about netting will be covered throughout the content, but additional topics of the net we will cover at the very end. The SLAs track, these will be covered throughout the content. And at the very end, we will talk about the net flow and all. SPAN, RSPAN, ERSPAN is part of the switching curriculum. Embedded packet capture, we will talk about. Packet data path, packet trace, conditional debugging, these we will talk about. But these topics, these small topics, these additional topics we will cover at the very end of our content. So in the infrastructure security and services, first we will focus on the QoS, quality of service, and then after we will talk about all the small content in our enterprise infrastructure. Everything will be covered except for this software defined networking and infrastructure automation and program. Except for these two things, this part will be covered, this part will be covered, and this part will be covered completely. Here also, like whatever topics of switching technology is there, we will not talk about that in our routing content. There is a dedicated class for the same. But apart from that, everything else will be covered in our routing content. There are dedicated classes for the SD-WAN SDA. So there are dedicated classes for SD-WAN SDA. So that 25% content gets covered there. And for infrastructure automation and programming, there are dedicated sessions. There are dedicated classes. There are dedicated recorded sessions also available. So most probably this content that is there, infrastructure automation and programming. Typically, this content is delivered in a video recorded format. Data encoding formats, automation and scripting, EEM and all that thing we can talk about. Guest shell I can talk about these things actually. For example, like when it comes to programmability, they want you to know about the vManage API. Now, what is vManage? vManage is a controller for the SD-WAN. So until you have covered the SD-WAN, you will not be able to understand this part. Until you have covered the SDA, you will not be able to understand this part. So the point is that they don't want us to know in and out of the complete programming and all that thing. They don't want that. They don't want us to know all that. They just want us to know what are different types of data formats. When one application program wants to communicate with another application program, in what format like they can communicate with each other. When one application program wants to communicate with another application program, in what format, what are the different data formats, that can be used by these application programs to exchange the data. So data formats, data encoding format, JSON, XML, YAML, Jinja. Jinja is a very common language for templates. Whenever you go through the templates section in our SDA, then you will hear this word Jinja. Velocity, for example. These are a few common languages for the templates actually. So they want you to know the formats of JSON, XML, YAML, Jinja. Then they want you to know what is this EEM, Embedded Event Manager. What is this guest shell option that we have in the iOS XE devices? What this guest shell provides. What can we do under the guest shell? Like, under the guest shell, can we do like Python scripting and all that? What things we can do under the guest shell? That thing. And then they just directly jump to the software-defined networking programming. They directly jump into the vManage APIs, which we talk about actually at the end of our SD-WAN content. Like in the SD-WAN, we do talk about the APIs. At the end of our DNS Center content, we do talk about the APIs. So that part is a little bit covered in the SD-WAN SDA classes. But this part, for example, this we do not cover in the SD-WAN or SDA classes. I can, at the very end of the content, if there is some time left, I can definitely talk about like EM and guest shell. I can tell you the formats of the data in the JSON XML, but mostly this section mostly is delivered in a video recorded format. Because for you, all these things will make more sense when you have gone through the SD-WAN classes and the SDA classes. So it does not make any sense at the moment like to cover this topic along with the routing content. So this is delivered, this content is covered at the very end in a recorded session format mostly. 15% of the content is infrastructure automation and programming, which covers like 3 sections: the data formats, automation and scripting in the iOS XE devices itself using EEM, using guest shell, and the software-defined networking, the SDN programmability, the vManage API. So they don't want us to know about the Python scripting a lot and all those things. Like they don't want us to go through each and everything from the automation programming point of view. For that, they have a dedicated content, by the way. For that, they have a dedicated content. If you go through here, you know that there is a dedicated content for the same, which is an auto. This enterprise auto. For this enterprise automation, this is a dedicated content that they have actually for the automation programming. They also have nowadays CCNA automation, CCNP automation, so which was earlier known as the DevNet associate, like professional. So now they have renamed it to CCNA automation, CCNP automation. So they have a dedicated track for the same. So as per our enterprise content point of view, you must know a few things regarding the automation programming so that you can interact with the SDN controllers like vManage, like the DNS Center, with the help of this thing called API, application programming interfaces, which is in fact covered in our SD-WAN SDA classes. Again, not in that much detail, but sufficient from our content. Right. So in our routing content, we will definitely not be talking about this part. This part at the very end, if some time is left, then I will talk about a few things from here. But the rest of the things are going to be delivered in the recorded session format. And like when you go through the SD-WAN part, when you go through the DNS Center, there we will talk about the APIs and all that thing. So what we will focus on is specifically, again, repeating the same thing: 30% from the infrastructure, network infrastructure, then 15% from the transport technology and solution, and the 15% from the infrastructure security and services. That too, here we will focus specifically on our routing content. We will focus specifically on our routing content. Whatever topics are there from the switching content point of view, that we will not talk about. Whatever other contents that are not relevant from our routing content point of view, that we will actually not talk about. Apart from that, everything else we will cover. Right. So this is, and again, this thing is repeated. This thing is, in fact, repeated when we talk about. This thing is, in fact, repeated in the encore as well. If you want to go through the encore content, here also, like, you will have the similar kind of thing. If you click on the exam topics here, so here regarding the routing, by the way, regarding the routing, So not the routing, not the routing, not the routing, not the routing. So quality of service, as you can see, the quality of service we will talk about as a part of our content, by the way. Again, then this is part of switching actually. So from this architecture regarding routing, we do not actually have a lot of things. Only this QS part, quality of service part, we will talk about. Under the virtualization, we will talk about VRF, GRE, IPsec as a part of our routing content. So that will be covered. Under the infrastructure, we will talk about the layer 3 OSPF, EIGRP, BGP, policy-based routing, all that thing we will talk about in our content. Then the IP services, we will talk about NAT, PAT, PIM, IGMP, and all that things. So this we will talk about in our content. Under the assurance, SNMP, syslog, SPAN, SLA, all these things we will talk about in our content. We will talk about all these things as a part of our content. SPAN, RSPAN, ERSPAN is part of switching. So of course, we will not talk about it here, but in the routing, about everything else, all the other topics, all the rest of the topics we will definitely cover here. Under the security, nothing that we will talk about in our content. Control plane protection is one of the feature that control plane protection and ACL. These are the two things that we will cover in our content. These are the 2 points. These are the 2 things that we will in fact cover in our content. Apart from that, other things we will not talk about in our content. And of course, automation programming. So netconf, yank, again, same thing, DNS center, vmanage, REST APIs, EEM, embedded event manager. So Ansible, Puppet, Chef, Salt, Stack, those agent or agentless orchestration tool is specifically part of the program. So this is what we will talk about. This is what we are going to talk about. This is the content that you must know that we are going to cover as a part of our routing curriculum. As a part of our routing content, this is all what we will talk about. Again, repeating the same thing, we will focus specifically on the content of the Enterprise Infrastructure Lab exam. Encore topics, whatever topics are relevant from the routing point of view in the Encore, those will also be covered. That is also there. But there are a lot of things that we will not talk about as a part of our routing discussion, such as like automation programming, such as wireless. In the Encore, we have a lot of stuff from the wireless point of view, a lot of stuff from the security point of view that we will definitely not talk about in our routing content. Right. So those things, this is the content that we must know what we are going to cover. There is a very good document, by the way. If you visit this link here, right here, if you visit this link here, if you scroll down here at the very end, actually, if you go to the enterprise track here, at the very end here, you have CCIE Enterprise Infrastructure 1.1 Learning Matrix. This one you can click here, and this is an Excel file, by the way. So you can just download it. You know, this under the additional resources right here, you have this CCIE Enterprise Infrastructure version 1.1 Learning Matrix. Similarly, we have the Encore Learning Matrix as well. Encore we don't really care at the moment. So Enterprise Infrastructure version 1.1 Learning Matrix, click on it. It will download an Excel file. And if you open it, it will, in the Excel, it will show you like, it will show you the list of all the topics that we have. It will show you the list of all the topics that we have in our enterprise infrastructure. This is for your reference, actually. This is for your reference. Here under the learning matrix, you have everything along with a link, actually. So for example, managing the MAC address, there is a link to the official Cisco documentation. There is a link to the official Cisco documentation. Same, like go for the EIGRP, configuring EIGRP. There is a link to a Cisco documentation, configuring OSPF, configuring BGP, you know. So just click on this link. When you click on the link, it will open the web page. There they will let you know how to configure things on the regarding the border gateway protocol. The entire document is there, right? So you can also download this book if you want to. This is download. You can download this book if you want. So this learning matrix, you can also configure IGMP, configure PIM, MLD snooping, and all that thing. There are plenty of links that they have provided for from the learning point of view. So do download this learning matrix. Keep it with you. And if you get some doubts or anything, you can always refer to the official documentation from the Cisco itself. So here is the programming and configuration guide for the how to do the programming, cell scripting, and all that. So it's a very, very good document, actually, that is provided by Cisco itself. So you can keep it with you and just go through the content, make sure that each and everything is basically covered. And if any topic is left, we can discuss about it. From the documentation point of view, you can refer to the official documentation from this Excel document itself. Right, it's right there in the link that I have provided to you. So you can just click on that link and download this learning metrics. I will also give you the link, by the way, for this page. So you can just directly click on it and just download the learning metrics for the enterprise infrastructure. And if you are preparing for the encore, then you can also download the learning metrics for the encore. Right. So this is the content. This is the content that we are going to cover. It's going to take a lot of time actually to cover all these things. To give you an idea, approximately in order to complete the routing content, only and only the routing content, approximately it will take, I will say 80 classes, approximately 80 classes, 80 classes approximately it will take to complete the content. So like, starting all the way from the introduction to routing. This is one document that I created earlier. You will have, by the way, a day-wise index actually. So introduction to routing, best path selection, static routing, default routing, a little bit about the NAT, VRF. Then EIGRP will take approximately like 1, 2, 3, 4, 5, 6, 7, 8, 9, approximately 9 classes for EIGRP. Then it will take a few classes for the OSPF. You can see type 1 LSA, type 2 LSA, type 3 LSA, type 4 and 5 LSA. So it will take quite a lot of time for OSPF content as well. And then right here we have the BGP, starting all the way from the 28 all the way to 47, approximately 20 classes for the border gateway protocol. 20 classes. I'm not talking about the 20 days. 20 classes I will need for the border gateway protocol. So fundamentals, connection type, packets, finite state machine, eBGP neighborship, iBGP neighborship, router reflector, peer group, peer template, path attributes, all the additional things. So approximately 20 classes for the border gateway protocol. Then IPv6 will take a few time as well. IPv6 will take 3 to 5 classes here, 6 classes here. IPv6 is going to take some time. Then we will in IPv6 we will talk about like all the protocols for the IPv6 as well. Static routing for IPv6, EIGRP for IPv6, OSPF for IPv6, BGP for IPv6, eBGP, iBGP for IPv6. So all the routing for IPv6. Then VPN technology will take quite a long time as well. So VPN technology, GRE, DMB-VPN, routing on DMB-VPN, front door VRF, IPsec, phase 1, phase 2, DMVPN phase 1, phase 2, phase 3, all that thing, approximately 6-7 classes for the DMVPN IPsec, and approximately 6-7 classes for the MPLS. So you can consider approximately 14-15 days for the VPN technology. So MPLS, LDP, routing, M+L3 VPN, import map, export map, basic discussion of the L2 VPN, OSPF sham link, some additional things we will talk about from the N+ content point of view, but it will be done in like maximum 6-7 classes. Then multicast like 1, 2, 3, 4, 5, 6, 7, approximately 7 classes for multicast, approximately like 3 to 5 classes for quality of service. So you can see approximately 78 classes, 78, and I can add up 2 more. So approximately 80 classes, 80 classes approximately it will take for the routing only and only for the routing content. It will take approximately 80 classes, 2 hours per day, approximately 160 hours of 150-160 hours of content is there in the routing. That much time you will need to cover the routing. The routing content is specific. Classes, of course, will be from Monday to Thursday. Classes will be there. Friday, Saturday, Sunday is going to be off. So you can revisit everything that we have done in the 4 classes in the next 3 days. You can do all the labs and everything. So classes will be like 4 days a week, approximately 80 classes.
Hey, Surinder.
Yeah.
So in CCIE Enterprise, right, which includes the encore topics also, right? So we don't want to follow separately on the encore part. Right?
You will have to follow separately on the encore, actually.
Even the exam topic.
Yes, correct. See, the point is that encore exam that we have. Encore exam is not only the written exam for the enterprise infrastructure, but it is also the written exam for the enterprise wireless. Okay. So The problem is that, for example, when we talk about routing, all the things that we cover in the routing here, those all the topics for the encore regarding the routing, they get covered here. When we talk about switching, all the topics from the encore regarding the switching, they gets covered. So no problem. When we talk about like SD-WAN, when we talk about SDA, when we have the dedicated classes for the SD-WAN, SDA, all the topics from the SD-WAN, SDA classes from the encore gets covered in those sessions actually. So that's fine. For those topics, you don't need to go through the encore content again. But the problem is that apart from that, apart from those routing, switching, SD-WAN, SDA, apart from those topics, there are like other topics as well, such as, for example, wireless, such as, for example, security, such as, for example, automation and programming. Especially when we talk about wireless, there are five chapters for the wireless. And in order for you to go through those 5 chapters, you first need to cover 4 chapters from the CCNA wireless. You know, in the CCNA also we have the 5 chapters for the wireless. So you will, if you are planning for the encore exam, by the way, so you will also need to go through these 5 chapters of the wireless, which we don't cover in our enterprise infrastructure content, because enterprise infrastructure does not include the wireless. There is a dedicated exam for the CCIE wireless, like, you know, enterprise wireless. So there is a dedicated exam, but unfortunately encore works as like, you know, as a written for both wired and wireless exam. So you will need to go for those additional wireless topics, security topics, a little bit about the automation programming as well. So extra content you
So
will
are
need.
you gonna share some kind of material for to cover those topics or?
Again, for since our content is specifically from the routing point of view, here we can't do anything regarding the same. However, for these pending topics, these remaining topics, they mostly give some video recorded sessions for the same. So some wireless videos will be there, some security related videos will be there, some automation programming videos will be there that you will have to go through. Plus, you will also have to go through the book, the official document, official certification guide. From there, you will need to cover the wireless, security, automation, and programming, and then you will be ready for the encore topic. So they will mostly provide you the video recorded sessions for these topics, but in the classroom training, these topics will not be covered.
And what about the virtualization and something?
Virtualization includes things such as like GRE, VRF, which we will talk about in our content, and it includes in the encore Lisp VXLAN, which is covered in the SDA content. You know, so just one topic is left in the virtualization section in the encore, and that is virtual machine, the VM hypervisor. 5-10 minute topic. You can easily watch some YouTube tutorials or just refer to some basic documentation on the same. Nothing special about that.
Mhm. Okay.
So it very easily can be covered. The only
Yeah.
challenge that you will face, I will show you the book in a moment. You will be able to cover everything, but for the wireless, security, and automation programming, you will need to go through some additional resources apart from what we are going to cover in our classroom training. Then only you will be ready for the encore exam. So this is the content. Let me know like if you have any queries from the content point of view. What things we are going to cover, it is going to take approximately 80 classes, so you can plan everything for next 80 classes accordingly. 80 classes and 4 classes per week actually, you can plan accordingly like that. 20 do we have any holidays? Yes, we will have a few holidays as well. 15th August is on Friday, so not a problem. A few holidays might be there here and there, so you will have to consider those as well. So approximately 22 weeks, 3 to 4 months, I will say it will take 3 to 4 months approximately to cover all this routing content only. Since it's a long time, you can plan everything accordingly, like your the labs and everything you will have to do from our content point of view. So you can plan the rest of the things accordingly. If you have some time and if you want to cover the content a little bit faster, what you can do, like for example, our routing is going on, and you can in parallelly you can join some switching batch. You can parallelly join some like SD-WAN classes or SDA classes, just in case if you want to cover the content a little bit faster. But if you want to go like one by one, completely up to you. Like you can go to the routing, then you can go for switching, then SD-WAN, SDA. You can also go like one by one, or if you want to cover the content, because I will be like, if you want to cover the switching content, it will take approximately 24 classes for switching. For the SD-WAN, a similar kind of content for the SD-WAN as well. Here, SD-WAN, you can see the SD-WAN takes approximately 26 classes. So 26 classes here. And SDA approximately also takes 25 classes. So 80 classes here, 24 classes, 26 classes, So 150 classes, by the way, na? 150 approximately 150 classes. 150 classes I'm talking about, like here 150 or 160. 150 classes basically going to be there. So understand that 150 classes approximates 300 hours. It is approximately overall content of the enterprise infrastructure is approximately going to take like 300 hours. Like 150, 160 classes it will take. 150, 160 classes it will take. This is I'm talking about from the weekdays point of view, 2 hours per day, 4 days a week. So approximately 160 classes, which is going to be quite long, most probably 7-8 months. So if you want to cover the content a little bit faster, you can join a few more technology batches in parallel, such as switching. It's not that hard. Switching is not that hard. Switching you can cover in parallel to the routing. Actually, it takes approximately 20 to 24 classes. So it is not, of course, and it is also not that hard. So you can cover like switching in parallel with the routing, just in case if you want to. Similarly, like for the SD-WAN, software-defined wide area network, if you have already gone through the routing content, or if you have already gone through the switching content, then you can join the SD-WAN classes, SDA classes. Not a lot of like in detailed routing switching knowledge is needed in the SD-WAN, SDA. A few things are needed, which gets very clear in the very first class when we discuss about the content. So if you want to cover a content a little bit fast, you can definitely join the batches in parallel.
Quick question,
Yeah.
Saurabh.
Yeah.
So do we have anything on SDN? I mean, APEC side of it, portion in the encore or enterprise?
Yes, there is a dedicated chapter for the software-defined networking, so software-defined infrastructure. 25% in the lab exam, and in the encore
But
also we, yeah,
but that will be like SD-WAN and SDA, right?
yes,
But
that is SDN.
SDN.
That is SDN. That is SDN from the Cisco point of view. Software-defined networking includes like two things: SD-WAN and SDA technology. So SD-WAN and SDA, that's what they have from our content point of view in the enterprise infrastructure.
Okay, let me rephrase my question. Do we have anything on the EPIC controller, like
No,
data center?
no.
EPIC.
That is data center is a different track. So that is
Okay.
DCACI that you are looking for.
Yeah, that ACI is not here part of this curriculum, right? Like,
Correct.
okay.
Correct. There is a dedicated certification exam from the data center. Data center is a different track actually. So the thing that we have to talk about from the ACI or the EPIC or the core technologies such as EVPN, VXLAN, those things. No, those are not part of.
Okay, okay. Thank
From
you.
the enterprise point of view, SD-WAN, SDA comes under the SDN. From the data center point of view, that is ACI, SEI, and all that. So in the enterprise infrastructure, the automation, the SDN relevant technology that we have to cover is the SD-WAN and SDA, which is in fact part of our more questions. Let me know. So plan accordingly, like have a provision for approximately 150 hours, approximately 3 to 4 months. Provision everything based on the same. We will have the classes from 8 to 10, in the morning. So plan everything accordingly for at least 3 to 4 months. If you miss some classes, you can revise it from the recordings. You will get the recordings by the end of the day. So once the class gets recorded, it gets in the processing, and you most probably will get the recording by the in 4 to 6 hours. You get the recording in the portal from where you have joined the classes. In the same portal, you will get the recording. Everything, like all the documents, recordings, and everything you will get from the portal itself. The Trainonic portal that you have joined, from where you have joined the classes. In the same portal, you will have all the resources, the study resources, the labs, and everything. Everything will be there in the portal itself. I will show you in a moment, but it will be there. This is one point that we have to discuss. We are just talking about the content. This is one point that we have to discuss the content that we are going to cover. We have to be very specific regarding the content. because in the lab exam, if you are planning for the lab exam or if you are planning for the encore exam, for example, so you will have to at least go through the curriculum, the content, and find out like what topics, what things they are asking in the exam as well. So we have to be very specific from the content point of view. This is what we will focus on. In order to complete all this content, you will have to refer to multiple books. By the way, I will be very honest, like there is no official book for the enterprise infrastructure. There's no book. There's no official study guide for the enterprise infrastructure. In older versions like routing and switching, we used to have the book like routing and switching, version 5, volume 1, volume 2. We had those books. Previously, we used to have TCP/IP volume 1, volume 2. Those books were there. But for the enterprise infrastructure, there is no official book actually, unfortunately. There is one book. There is one book that is Enterprise Infrastructure Foundation. There is one book actually, but if you go through that book actually, enterprise, let me just search infrastructure foundation. There is this book actually. There is this book, Enterprise Infrastructure Foundation study guide. There is this book actually, Narvik, this book actually, Enterprise Infrastructure a foundation. There is this book actually available on the Cisco Press. It's more like a lab workbook rather than it's not a technology. Actually, you can't read topics from there. It's just like from the lab point of view, there are things available in this book. So it's more like lab book. See, if you go to the sample content, just go to the index. Just take a look at the index.
Sorry, are you sharing something? I see like the complete list topics in the PDF format.
Yeah. That is what I'm sharing here. So can you see this Enterprise Infrastructure Foundation second edition?
Now I can see. Yes.
So if you scroll down in the sample content, you can see that it's just a lab workbook. There's no theory to read from here. So you can't. It's just like lab. All the labs, dual hub, single cloud, dual hub, dual cloud, M plus L3 VPN, just pure labs, all the labs. So it's not the book that you can actually read and cover the technology part. Not the lab. I'm not talking about the lab. This book is there. It is an official book from the Cisco Enterprise Infrastructure Foundation, second edition or whatever. But it's more like from the lab point of view. If you want to do the labs, when you purchase this book, they will give you some EVNG labs. You can load it on your VMware, and then you can just study from there. You can just do the labs. It's a lab workbook. It's not a technology work. So if you want to cover the technology, actually you will have to cover the encore. This one, the CCNP CCIE Enterprise Core Encore. This book actually you will have to cover. This is also not in very detail actually. So if you go to the sample content, which is going to list you the index, like index of the book. So here we have the chapter 1, which talks about like the switching. The chapter 2, which talks about the switching. The chapter 3, which talks about the switching. Chapter 4 also MSTP switching. Chapter 5 switching. So like here all the way up to this part 1. The part 1 of this book actually, part 1 of this encore book is actually, by the way, switching. The part 2 here starts from the routing. So routing protocol overview, distance vector, algorithm, link state, path vector, path selection, prefix length, AD, static routing, IPv6, whatever, VRF, policy based routing. So this is routing. This is then EIGRP. This is then OSPF. But it's not in that much detail. Then advanced OSPF. Then OSPF version 3. Then the BGP, the border gateway protocol, advanced BGP. Then multicast. Then quality of service, the QoS. Then the additional topics, the IP services. So it does cover the overlay tunnels, the GRE, DMVPN, IKE version 1, version 2, LISPO, VXLAN and all that thing. So overlay tunnels. So like part number 3, part number 4 and part number 5 of this encore book is part number 2 basically, part number 2, 3, 4. Part number 2 where part number 3 that talks about the routing. Part number 3 that talks about the routing. Part number 4 that talks about the services. These two parts, part number 5 that talks about the overlay tunnels. These 2-3 things that we have in our encore book that you can go through. But you will notice that it's not in that much detail. So apart from this encore book, you will have to refer to some additional books as well, such as some old routing and switching, the old CCIE routing and switching version 5, the old volume 1, volume 2, the TCP/IP volume 1. There is a dedicated guide for quality of service. There is a dedicated study guide for the MPLS. So there is a dedicated book for the VPN actually. So you will have to refer the content from different books. All the books will be available to you, but remember that they will be made available to you. But remember that all the things you cannot cover from just the encore book, because it just covers things like in more like an overview. There's not like a lot of details actually that we should know from the lab exam point of view. So those topics are those covered from some other books that you will have the access to. So you will have to. I will throw out the content. I will show you like what topics you can refer to from where. But this is one of the book that you can refer to. Not going to be in that much detail, but still very much relevant from the lab exam and the encore exam point of view. And just go through the after topic, like you see. Then afterwards you have the wireless. So one chapter for the wireless, the second chapter for the wireless, and then the third chapter for the wireless, then the fourth chapter for the wireless, and the fifth chapter for the wireless. There are 5 chapters for the wireless. Then you go for the design. Here they talk about the software-defined WAN, SD-WAN, SDA, SPAN, RSPAN, ERSPAN, SNMP. So what is this? Take a look at this. How, are you supposed to know all that? This is security. They want you to know about the network security designed for threat defense, next-gen security, Talos, threat grid, AMP, AnyConnect, WSA, ESA. In WSA, they have given, by the way, before attack, during attack, after attack, ESA, email security appliance, then next-gen IPS, next-gen firewall, FMC, stealth watch, ICE, network access control, .1x, map. This is what you should know from the security point of view. In the encore exam, not in the lab exam. In the lab exam, you don't need to know all that. But from the encore exam point of view, you will have to know about all these products that they have offering a different level of security in the enterprise network. And just go below it, the chapter number 26, again security. You see, the zone-based firewall, AAA, control plane policing, ACLs, and port-based ACL, numbered ACL, named ACL, different security features are there. So you can't possibly cover all that thing, being some enterprise person. So these topics specifically can be covered from some trainer who is well into the security track. So I generally do not touch these topics. So these topics are basically recorded. You are given the video recording access for all these topics from some security trainer. This is what I was talking about. Then SDN, virtualization, then the REST API, the data formats, automation programming, Ansible, Puppet, basic things about the EEM, Ansible, Puppet, and all that thing. So basics of automation programming. So even after covering like all the topics from the CCIE, routing, switching, SD-WAN, SDA, a lot of topics will still be there in the encore content that you will have to go through from the official book before you can take the encore exam. You can refer to some documentation. You can refer to some this content. This content can be covered from this encore book. This book will be made available to you like this, and along with this, like other books are also going to be there that you can refer to from our content point of view. You will complete the content using all those books. For the labs, we will be using EVNG, by the way. For the labs, we are going to use EVNG from our routing point of view. All the labs that we will be doing, we are going to use it on the EVNG. So EVNG, either community edition or pro edition, whichever you have. So we'll be doing the lab on the EVNG. There are some lab topologies that will be made available to you again with the help of the portal, the Trainonic portal. So from there you can download these different lab topologies that we have, and as our content starts, you can start working on those topology throughout the whatever I do basically in the class, whatever discussion we have in the class, You have to do it yourself in your free time. Whenever you get some time, you can repeat all those things that we have done from the lab point of view. So we will have plenty of lab topologies as well. Just to give you an idea, let me quickly show you these are the, by the way, these are the different lab topologies that we are going to have here. So here we have like static routing, EIGRP, OSPF, BGP, IPv6, VRF, policy-based routing, VPN, multicast, then quality of service. So we'll have like different labs. So if you click on the static routing, you'll have a basic static routing topology, right? If you click on like, let's say EIGRP, you'll have a basic EIGRP level of topology. If you click on like OSPF, you will have a basic OSPF like OSPF topology basically. It's not going to be a small topology, but yeah. Same goes for like others as well, such as BGP and all. So you will have some BGP topologies respectively. So you will have different topologies, and all these topologies will definitely be made available to you through the portal actually. So these topologies you can get from the portal. These are IP address and everything is pre-configured in this. You just need to cover the topics regarding the static routing, topics regarding the EIGRP, IP address and everything is covered, already configured. So you don't need to configure the IP addresses on there. You just need to focus on the protocol specific configuration in all these topologies. Same it will be for other as well. This will be in EVNG. You will not need like a lot of resources to run these topologies. If you have like approximately 8 GB RAM, it will be sufficient. All these routers and switches that we are going to use, they do not consume the CPU. So CPU is not going to be any problem. If you have like 8 GB or 16 GB RAM in your laptop desktop, so that will be sufficient. Will not need more than that. For the routing purpose, for the switching actually, we don't need a lot of resources. So 16 GB RAM will be enough. You will not be able to practice like SD-WAN, SDA, those things. This is purely from the routing point of view.
Hey, Surinder.
Yeah.
So you're gonna have to have the same exact images for those switches and routers and all those devices, right? Or it won't, or it doesn't matter.
No, we will have the, again, just like in the switching, we were working on a specific image. On the routing, we will work on the 15.7 image. It is the most stable image that I can find actually, with all the features working properly without any problem. So 15.7 we will be working on. I will provide you the link to download that particular image and load it on the EVNG. So you can refer to that. But we'll be working on that 15.7 image of the, and we will be using IOL based devices that do not consume any CPU. They just consume the RAM. We will not work on the VIOS, we'll not work on those VIOS devices. They consume both actually CPU and RAM. So we will work on the IOL devices. So the CPU will not matter. The RAM, however, if you have like 8 GB, 16 GB, that will be sufficient. All these files will be given to you. If you have the access to the portal, you will have the access to these files as well. So I will show you how to upload the files, how to upload all that thing. We'll definitely talk about it. But the point was that we will be practicing on the EVNG for our lab session. And just in case if there is something that we can't mimic in this, some like protocol or something, some particular command we are not able to run in that, then that I will run on some real devices that we have here. And you can just refer to the configuration commands, or when you get the chance to work on some real devices, then you can try to run those commands. However, I don't recall any such thing. A few things are there, definitely. A few things are there that do not work on the simulated environment on this EVNG platform. A few things are there, just like in the switching we had a few things. In the routing we also will have a few things that will not work on the EVNG. So for that I will generally refer to some real devices, or I will just let you know the configuration commands that you have to run for those particular features. But mostly 99% of things we will be able to complete in our EVNG. So make sure that you have at least 8 GB RAM machine available with you with the EVNG installed, so that you can just load the lab and just pre-config is already there. You can just start doing the practicals. You can just start doing the labs that I'm going to do in the classes. And see, the idea behind the technology class is basically to make you aware with different fundamental concepts of the protocol. It's not like we have to work on a very big topology or something like that. It's not like we have to just configure it. We have to here understand the concepts of route advertisement, route filtering, path manipulation, and all that thing. So whatever I do in the classes, just repeat. Whatever I do in the classes, just repeat whenever you get some. That will be sufficient. That will be enough from the lab exam point of view. That will be enough from your technological understanding point of view. And just in case if you have any doubt, you can discuss it in the next class. We will also have a WhatsApp group, by the way. I will add you to that WhatsApp group after 3-4 days once I get the list of final candidates. Although I believe like everyone is here already enrolled. So once I get the confirmation from the management that, okay, this is the list of the final candidate, then I will share you a link to a WhatsApp group that you can join. That is there for the CCIE routing discussion. So when you're doing some labs, you get stuck in some problems, and then you can drop a message in that group. Right, so we'll be doing the labs on the virtualized environment, especially on the event. A packet tracer we will not do. The GNS and all those things we will not do. We will just work on the EVENG environment. If you don't have the EVENG, if you don't know how to install the EVENG, you can drop a message to your accounts manager, like, whoever you are in contact with here, you can drop a message to your accounts manager. They will connect you to the lab admin, and lab admin will then take they will share you the link to download the EVENG and all that thing, preloaded with all the images and all. So you can download that link, and then they will take the remote access, and then they will set up the lab for you. If you, just in case if you are not able to if you're not able to, deploy the EVENG by yourself, you can take the help from the lab admin here. They will do it. Right. So this is the overall picture. This is the overall idea. This is the overall discussion about the content, the timing, the books, the labs, all these things that we are going to do throughout our content in next 3-4. This CCIE routing content that we are going to talk about, it's not going to be of course, it is not going to be a beginner level classes. So although there is no official prerequisites or anything like that, but there are a few things that you must already know, like some fundamentals, some basic fundamentals of things you must already know. For example, you must already know what exactly is an IP address, what is IPv4 address, what is IPv6 address, how to write down the IPv4 address, IPv6 address, what is subnet mask, what is subnetting, what is VLSM, what is FLSM, those things. The basic routing, what is OSPF, what is EIGRP, what is BGP. The basic, I'm not saying that very advanced level, but you will have to know the basic fundamentals of these things. Like I'm not going to tell you what is an IPv4 address. I'm not going to tell you, although we'll talk about the IPv6 from the scratch, but I will not tell you like what is an IPv6 address. I will not tell you about the subnet mask. I will not tell you about the subnetting. I will just directly use the subnetting. We will talk about EIGRP from the scratch. We'll talk about the OSPF, but at least I will expect that you know what is EIGRP, what is OSPF, what is a distance vector protocol, what is a link state protocol. So a basic level of understanding of the routing protocols, routing technologies, routing terminologies, you have to have already, right? So what I'm trying to say is that if you have gone through the lower level training such as like CCNA or CCNP, that will be helpful in covering the CCIE routing content a little bit faster. If you don't know, for example, a few topics such as MPLS, such as VPN, such as multicast, that I understand that these are completely new topics. Fine, no problem. But these fundamental topics such as IPv4, IPv6, subnetting, EIGRP, OSPF, BGP, these are covered in the CCNA and CCNP level of training. So the basic things at least you should know. What is, like, for example, what is the syslog? What is this SNMP? The basic things. These are covered in CCNA, CCNP. I'm not saying that you have to know about them like in very advanced level, but at least you will have to have that fundamental understanding of these things. So just the CCNA training will not be sufficient actually. If you have done only the CCNA and then you are directly going for the CCIE with no exposure to the production environment or anything, it will be a little bit hard for you to catch all the things. I'm not saying that you can't do it. You can do it, but you will have to spend like more time in studying the technology, the protocols, as compared to if you already have some production experience of these protocols, EIGRP, OSPF, BGP. I'm not saying that you have gone through the CCNP level of training or CCNA level of training, but if you have some production experience of this protocol, of these EIGRP, OSPF, IP addressing, subnetting, and all that thing, that is also sufficient. Overall, what I'm trying to say that it's not a beginner level class. It is not going to be an associate level or a professional level class. It is going to be an expert level class. So I expect that you already know the fundamentals of like basic things such as IPv4 addressing, subnetting, IPv6 addressing, basic protocols such as EIGRP, OSPF, these things you will have to have the understanding of. This is all the things that I have to talk about from the content point of view, all the materials, study materials, and all those things from where we are going to get and all. This is all. This is all the things that we have to cover. We will cover the content from the PPTs, of course. The PPTs will be available. The PPTs will be available on your portal. You will not be able to download the PPTs, of course, but the PPTs will in fact be available on the portal. You can refer to these PowerPoint presentations. You can refer to these PPTs from the content point of view. Of course, you will not be able to download these PPTs. Any questions, any point so far? We are done with the basic discussion. This is it. This is like the expectations that I have, like what things you should know, what things you must know before starting the classes and all. So how we are going to do the labs and everything. This is done. The complete discussion is now done. If you have any queries, any doubts, any questions, you can ask. Although we don't have that much time today, but we can start with the basic discussion of the routing. But before that, like any questions, any point, if you want to ask anything you want to clear regarding the lab, regarding the documents, regarding the content, anything, let me know.
Hello, Surendra.
Yeah.
I just one basic question regarding the timing.
Okay.
It is 8 to 10 a.m., right? Yeah.
Right.
Will it extend from beyond 10 a.m.?
No, it's not possible because 10 to 12 I already have another batch. So I'll be starting like 8:05 maximum, and I will leave approximately at 9:55. So that is the max to max that we can have at the moment. For like longer time period, you might need to go for the weekend batches. There we have like 3 hours per day, but 8 to 10, because after 10 a.m. like I have another batch, so 8 to 10 will be the official timing for the classes. I will start like 8:05 maximum to maximum, and 9:55, 9 approximately till 10. So you will have like a good like 145, 150 hours of content. If needed, we will have a short 5-minute break in between so that you can refresh up a little bit, and then we can. So you will have like approximately 1 hours 45 minutes of like the technological discussion of the content. So do download all the relevant resources, download the content PDF, download that learning metrics, and in that learning metrics you have a lot of hyperlinks that will redirect you towards the different documents of the Cisco. So download it, download those documents if you want to, or just bookmark it as per your requirement, so that you can refer to all those things. This is, we have already covered whatever topics we are going to cover. We already have talked about it. Although there is no prerequisite for the course, but one should be familiar with the basic technological concepts such as switch management, basic EIGRP, OSPF, BGP. Recommended to have NRC and encore training for detailed discussion of the topics going for the enterprise infrastructure. So it is expected that you have gone through the CCNA and CCNP level of training before you go for the CCIE. But anyway, if you have not gone through the encore level of cert training, it's fine, not a big deal. Throughout the content, it will be assumed that you already have at least basic to intermediate level of understanding of the topics such as IP addressing, subnetting, then OSPF, EIGRP. The basic understanding you already have of the topics. So if you need to revise a few things, you can definitely revise before the classes. Like for example, if you have to start EIGRP tomorrow, and if you don't know about EIGRP, you need a refreshment, like you need to refresh the EIGRP, you will have some time to refresh the EIGRP from the official documentation, from the YouTube videos. You will have plenty of ways to do. But I will assume that you know at least basic things regarding those topics. Then only we will be able to complete it in 150, 160 hours. Otherwise, if I start everything from the scratch, it will take way more time, to be very honest. Right? So that basic discussion is now done. So now we will start from the routing fundamentals. We'll talk about like what exactly is the routing, how to perform the routing in between 2 or more devices, what is routing, how the routing is done and all that. Now we will talk about it. So what exactly is the routing, by the way? Routing is like sending the packets from one network to other network, a process of forwarding the packets, from one address to another. The process of forwarding the packets on the basis of the layer 3 address is known as IP routing or layer 3 forwarding. Layer 3 address, of course, it's IP address. Forwarding of the packets based on IP address is what we refer to as IP routing, also known as layer 3 forwarding, because IP address works at the layer 3 of the OSI model, network layer of the OSI model. IP address is also known as the layer 3 address. So forwarding of the packets based on the layer 3 address is known as IP routing or layer 3. Devices that can switch the packet based on the layer 3 address, they are known as layer 3 devices. Devices that take their forwarding decision based on layer 3 address. Layer 3 address means again the IP address. So the devices that can take their forwarding decision based on the IP address are typically known as the layer 3 devices. Common layer 3 devices are like router, layer 3. Others are there as well. Like you get routing functionalities on plenty of devices. Routing functionality basically means like ability to forward the packets based on destination IP. Not only routers and switches. Commonly routers and layer 3 switches. Commonly these routers or layer 3 switches are used for routing. But apart from that, we have other devices also that can perform the packet forwarding based on the layer 3 address. Now, when a packet arrives on a router or when a packet arrives on that layer 3 device, when the packet arrives on this layer 3 device, the layer 3 device needs to decide out of which interface the packet needs to be forwarded. When the packet arrives, the packet will have a source IP, packet will have a destination IP, packet will have a source MAC address, and the packet will have the destination MAC address. Since the layer 3 devices, they perform their forwarding decision, they take their forwarding decision, they perform routing based on destination IP. They will, since they do the packet forwarding based on the destination IP, they will check the destination IP, they will find out of these three interfaces which interface is appropriate to forward the packet for that particular destination. These layer 3 devices must know out of all these three, for example, interfaces, which interface will take me to that particular destination. If I send the packet out of this interface, will I reach to that destination? If I send the packet out of this interface, then I will reach to that destination. Or if I send the packet out of that interface, then I will reach to that particular destination. When the packet arrives, the packet will have the destination IP, but this router will have to refer to this layer 3 device, has to refer to some sort of table in order to find out if I have to go to that destination, out of which interface the packet needs to be forwarded. These layer 3 devices, they maintain a table. Based on which they can decide in order to go to a certain destination, which interface is the appropriate exit interface. That table is known as the routing table. The layer 3 devices maintain a table called the routing table. In that routing table, they maintain the information about different destinations, that in order to go to that destination, in order to go to the destination A, the exit interface is FA0/1. In order to go to the destination B, the exit interface is FA0/. In order to go to the destination C, the exit interface is FA0/3, for example. These devices, they maintain a table called a routing table. In that table, they maintain this information that in order to go to the destination A, B, or C, which interface is the appropriate interface to forward the packet. All they care about, in fact, the layer 3 devices, these routing capable devices, all they care about is, in fact, the exit interface. Like if I have to forward the packet, which interface is the exit interface for that particular destination? They will look up the routing table. They will check the routing table. They will perform this thing called routing table lookup. They will look up the routing table. They will see that if I have to go to the destination B, the exit interface is FA0/2. So they will place the packet from the interface FA0/3, FA0/4, or whatever it is. They will place the packet from one interface to the other interface based on the destination IP address. This table that they have maintained, this table that these layer 3 devices have maintained, this routing table, this table that these devices have maintained, this table is going to be used in order to maintain in order to maintain the exit interface information, which will be used by the layer 3 devices such as a router, such as a layer 3 switch, in order to decide which interface is going to be the exit interface. To know the exit interface, devices look up a table called a routing table. In the routing table, we have something called routes. In routing table, we have these things called routes. There is a route to reach to that destination. There is a route to reach to that destination. There is a route. There is a path to reach to that destination. There is a path to reach to that destination. These are what we refer to as routes. In order to go to that destination, here is your exit interface. In order to go to that destination, here is your, this is called a next hop. In order to go to that destination, here is your exit interface. In order to go to a certain destination, what is your exit interface that is mentioned there. Apart from the exit interface, of course, the routing table will contain a lot of other information, such as the routing table contains the network ID and subnet mask. A routing table contains the exit interface. A routing table contains this thing called a next hop. Routing table contains how have you learned about that particular route. A routing table contains the AD value. Routing table contains the metric value for that particular route. How trustworthy that information is. What is the metric to reach to that particular destination? All that information is maintained in this tabular format, in this table format referred to as the routing. A routing table contains something called a network ID and subnet mask. A routing table contains this thing called a code. Code represents like how you have learned that particular routes. Routing table contains the AD value, metric value. A routing table contains the next hop IP address. A routing table contains the exit interface. Routing table contains various information about a particular destination network. By the way, what do we mean by this? We mean that as per the entries available in this router, as per the entries available in the router routing table, this means that this router knows how to go to 10.1.4.0 to 10.0.4.0 to 10.0.4.255. This means that whenever the router receives any packet that has the destination IP of this range, the packet will be placed out of the interface gigabit 0 by. This, for example, means that the router has a route to go to the destination 10.11.40.96.0 all the way to 11.40.96.250. In order to go to that destination, the exit interface is whatever it is, 0 by 1. This IP address and mask actually represents a range of destinations reachable from that router point of view. From this router point of view, what are the destination IPs that are reachable? Those are mentioned in this IP address and subnet mask format in this table referred to as the routing table. The routing table does not install the information like individually. It is not going to maintain the information about each and every IP address reachable from that particular range point of view. It will instead just maintain the network ID. It will just maintain the network ID and subnet mask. It will just maintain the network ID and subnet mask, which eventually means a range. Based on the entries available in the routing table, the device, the router, L3 device, whatever it is, will be able to or will not be able to forward the packet for a certain destination. If the entry is present in the routing table, packet can be forwarded. If the entry is not present in the routing table, packet cannot be forwarded. Destination-based routing. Based on the destination IP, the routing is done by all these layer 3 devices. In the routing table, you will have here the destination, basically network ID and subnet mask, which is going to mean a range. So in order to go to that range of IPs, if you want to forward the packet to any IP in that range, you have to place the packet out of the interface 0 by. That's what it means. Other information is not so much relevant at the moment. When it comes to packet forwarding, all the router cares is that there is route in order to go to that destination. If you have the route, packet will be forwarded. If you don't have the route, packet will not be forwarded. How you have learned about that route is a whole different story. how we have learned about that route. Basically, understand that a router or a layer 3 device, whatever we have, it performs two tasks. It has to take like two tasks. One is like routing decision, and one is like the forwarding decision. Like there are two tasks performed by these devices. Like first, which route will get installed in the routing table, and second, how the packet will be forwarded based on the entries available in the routing table. We will talk about it in detail, but understand that the router needs to take two decisions. First, like it has to decide, first of all, that it has to decide which out of all these routes, what routes gets to installed in the routing table. And the second is like out of all these routes, which route will be used to forward the data. So we will have all these entries available in the routing table, and based on that the packet forwarding will happen. We'll explore more options in the routing table. We'll talk more about it. We'll take an example. I will take an example of this topology. I will build this topology in the EVE-NG, and then I will ping from the PC and the server, and we will see how the packet forwarding basically happens between all these devices. We have to understand the process and all that. We will talk about like how the packet forwarding will happen. I will give you a brief overview of all the things that you already know, like how the packet forwarding happens from the PC to the PC, from the device to the device, from one network to the network. We'll talk about the process of ARP, the process of like ICMP, Telnet, SSH, all those things we'll discuss about that in our upcoming class. This is just the introduction of the topic.
One quick question.
Yes.
Can you please go back to the previous slide? The
Okay.
AD/metric value, right?
Correct.
AD/metric value. Yeah. Can you go back to the other slide where the actual routing entry? Yeah, here. Can you just throw some light on AD/metric value?
Yeah, this one.
Here.
This is, for example, right here along with the route, we have this AD value, and here we have the metric value.
Okay. It's only for routed protocol. I mean, routing protocols. It's not for directly connected networks.
Directly connected routes. They have the AD value, and they have some AD value and metric value, but it's not visibly shown here. When we open that information in detail, then it will more like show that information. Directly connected routes, they have the AD value of 0. It doesn't show you, but there is some AD value associated with that.
Okay.
It will not show you here. It will not show you in the show IP route in this routing output. It will not show you. But directly connected routes, they have the AD value of 0, and there's no metric associated with those directly connected routes. Just like the static routes does not have any metric value. Similarly, like directly connected routes, they do not have any particular metric. But they do have the AD. They do have the AD. They do have, like all these protocols, they have the AD.
Okay, AD is the administrative distance, right?
Correct. AD is the administrative distance, and metric is basically how the best path was decided, based on which criteria the router or routing protocol has decided the best path.
Okay, could you please explain this metric value, how this makes this significance?
It will be covered throughout the content. We will talk about it. Each routing protocol has a different way to decide which path is going to be the best path. So we will definitely talk about it throughout the content. Right, so that is it for today. You can revisit this class from the recordings once it's available. And just the basic introduction of the routing we have started. We will tomorrow build a basic topology. And from here, we will continue. We'll talk about the protocols, the algorithms, the metric, the AD, and all that thing we will talk about in our next class. In last class, we covered the basics of the IP routing. So we discussed like what is IP routing, what is the routing table, how the routing table looks like, what are the components in the routing table, such as like the network, then we have the AD, then we have the metric and all that thing. Let's do one thing. Let's create a basic topology, something like that, and configure the IP address and everything. And let's see how the routing process will work. When we ping from like the PC to the server, how the routing process will work. Let's talk about it. So I will be using the same EVE-NG software. And in that EVE-NG software, I'm going to build this basic lab. In this basic lab, we will talk about like how the packet forwarding process basically works. This is EVE-NG. I'm going to take a few nodes here. So nodes, if you don't know how to operate on EVE-NG, you can watch a few tutorials on the YouTube to know how to work on the EVE-NG. So here is the EVE-NG platform. Here I will right click on the this workspace, and I will click on the node, and I will take a few IUL devices. I will take the router. I will work on this router that is like a 15.7. This is This is like we can also work on 15.8 or 15.9, but whatever things are in our content, all those things can be covered in 15.7. Also, like 15.8 operating system, like I have observed a few problems in that, so I still prefer to use this 15.7 version of the iOS. So 15.7, I will take like 2 routers total, and as per the diagram, here, like between the routers, we have to take a serial interface. Instead of using the serial interface, or let me, just for the sake of the topology, I will take a serial interface as well. So here, right here, under the serial port group, you can add one serial interface here. So you have one, like 4 Ethernet interfaces, and now you have 4 serial interfaces. So on this router that I have added, apart from that, everything else is okay. So there are 2 routers that I have taken. So router 1 and router 2. They are connected via the serial interface. So I will connect these 2 routers via the serial interface. So serial. Then I will take although I don't need to take any switch here because it's just the 1 PC. But again, as we are building the topology from the diagram, I will take 2 switches here as W. And for the switch, I use this image 2019-0423. This is probably one of the most stable images for the switching that you can go for. So this one, we don't need to do anything on the switches. I don't need to configure anything on the switches. It is just there to connect the PC with the router. So nothing that we have to configure. So I will take 2 switches here. I will change the symbol to like I will change the symbol to match the switch icon. So I will take the symbol switch. So here is like switch number 1, by the way, and here is, on the other hand, we have the switch number 2. Right. So here is switch number 1. Here is switch number, and I will connect them via 0 by 0, 0 by 0. Okay, correct. So that is going to be fast Ethernet 0 by 0. And here it's going to be also 0 by 0. By the way, in this EVNG platform, we do not have the fast Ethernet. We have the Ethernet interfaces. So Ethernet interfaces we have. In this IEL devices, we have the Ethernet interfaces. The difference in the Ethernet and fast Ethernet is pretty much obvious. In the Ethernet, we get 10 Mbps. In the fast Ethernet, we get 100 Mbps. But the speed is not going to matter in this topology. The speed and everything does not matter. So here in this topology, they have taken the fast Ethernet interfaces. In EVNG, the IEL devices that we are using, there we are going to use Ethernet interfaces because that's what is available there. You cannot add fast Ethernet interfaces in those devices. Then I will take 2 PCs, by the way. And for the PCs, what I'm going to do actually, I can take a PC here from here. Here at the very end, we do have like some virtual PC. So I can take a few PC, but I'm not going to take these PCs. Instead, I'm going to take 2 new routers. I will take 2 routers. And I will basically configure them as the end devices. I will take 2 routers here. So I will select the appropriate images. I will take 2 routers here and I will change the symbol to match the computer. So I'm not going to, or desktop, whatever you want to call it. So I'm not going to basically take like here. I'm not going to take like the PCs. I can take the PC. I can take those virtual PCs, but I'm not going to take those PCs. I'm going to take a router here and I'm going to change the symbol of the router actually to match with the diagram. And the reason why I'm taking the router, because we will be able to then enable the telnet services, SSH services, those things which we cannot do in the PC actually. So I'm just going to take the PC rather than using the router, right? So desktop and 2 PCs. So I will make these routers act as the PC, right? So this is one of the host and this is another. This is, by the way, server, and I'm going to change the symbol to match it with the server actually. Symbols does not matter, by the way, symbols does not matter. You can take whatever symbols you want to. So here is how I'm going to do the connectivity. So this is the diagram that we will be working on. This is the topology that we will be working on, which is exactly similar to what we have, what we are seeing here in this particular diagram. Just instead of using the PC and server, I have used like the routers, and I'm going to make them act as the PC or as the server actually. Second thing is that here we don't have the fast Ethernet interfaces. Instead, we have the Ethernet interfaces. So that is another difference. And yeah, that's pretty much it. Serial interfaces we also have. Then I will configure the IP addresses. I hope you already know how to configure the IP and all. So I will start all these devices and I'm going to configure the IP address on here. As per the diagram, what we had to do, we had to configure the IP 192.168.1.2/24. That is the IP which we have to configure here. Then here we have the IP 192.168. This I'm not going to write down again and again. This is, since it's a first class, I'm just going to write it down. Like after today, like we will not be writing down the IPs and all that. So 192.168.1.1, 1.2, and then here we have 2.1, 2.2. Here we have 2.1. This is going to be 2.1 and /30, by the way, as per the diagram. And this is going to be 2.2. This is going to be 2.2/30. And then 3.1, here I'm going to say 3.1/24. And here I'm going to say 3. There is a, this is how we have to configure the topology. As you can see, 1.2, 1.1, 2.1, 2.2, 3.1, 3.2. So /30/24. That's what we have to configure. Then they have also configured, by the way, the MAC addresses. The way they have configured the MAC addresses, like they are considering the MAC address on PC all once basically, which you can't configure, by the way. Here you have configured, here they have configured all A, here they have configured all B, here they have configured all 2s. So what I'm going to do, I'm also going to configure the MAC address. So although we generally cannot change the MAC address, but I am going to configure the MAC addresses on these devices as well. So the MAC address is going to be a AA, BB, CC, 00, and 1000. This is the MAC address that is going to be, this is the MAC address that I'm going to configure on the host. AA, BB, CC, 00. I don't need to change the MAC address, by the way. It is just so that we can understand the process properly. We don't really need to change the MAC addresses. Devices, they will already have the MAC addresses. But since we want to understand the process properly, that's why I am changing here the MAC addresses on these Ethernet interfaces, by the way. Otherwise, I did not need to really change any MAC addresses. So AA, BB, CC, 00, 1002, 1001 here. On the serial interfaces, we don't have the MAC addresses. So here we have to configure the MAC addresses. I will configure it like 3001, by the way, and 3000. I really do not need to change the MAC address. Again, repeating, when you do the lab, you don't really need to change the MAC address. But I'm changing the MAC address because when we try to understand the packet forwarding process, it will be a little bit easy to understand how the things are going on if we have configured the things accordingly. It will be easy in the packet captures and all that thing. So that's the only reason I'm changing the MAC address. Otherwise, I did not really need to change the MAC address. So this is the topology that we'll be working on. And here we will understand the concept of, here we'll try to understand the process of the IP routing, like how the routing happens, all that process. The packet forwarding process, basically, we are going to understand here in as much detail as we can as per our curriculum. Although it's really not part of our content. It is just more like a prerequisite. It's more like a thing that you must already know. But anyway, let's repeat one more time. There are two routers connected via the serial interfaces as per the diagram right here. Then we have like these two end users. I have taken routers. So I could have used the PC, but then I cannot enable the telnet SSH services. So as the end user, I have used the PCs. So host 1, server 1. These, by the way, are the routers that I'm going to make them act as the PCs basically. So host 1 and server 1, they are just routers. Right, and the IP address, MAC address, IP MAC. Serial interfaces, they don't have the MAC addresses, by the way. Serial technology is a point-to-point technology. In the point-to-point technology, we don't require the MAC addresses. We don't require the MAC addresses. And when we talk about the Ethernet technology is actually a multi-access technology. Ethernet technology is a multi-access technology. In the multi-access technology, we do need the MAC addresses. We'll talk a little bit more about it later on, but at the moment, just understand that the serial interfaces, they don't have the MAC addresses. Also, note that while configuring the topology, I will have a few questions. I will ask a few questions that you will, find. You will be required to find the answers to those questions. I will not answer it, of course. If you know the answer, good. If you don't know the answer, then you can look up online. You can do some research. You can just try to find the answers to those questions. So let's start configuring let's start doing the configuration, and let me start from router 1. I will start from router 1, and I will also capture, like right click, capture, and I will capture the packets going out of the interface 0 by 0. So capture 0 by 0. You can't do the capture on the serial interfaces, by the way, in this software. Even G, you really cannot do it. You can't capture the serial interfaces here, no option. So I'm going to just capture this interface. Any packet comes in, goes out of the interface 0 by 0, that I'm going to capture. So let's start from router. This is the router 1 command line interface. So here, enable, configure terminal, host name, router 1, interface is 0 by 0, no shut. IP address 192.168.1.1 255.255.255.0. Now, of course, I will not tell you what is IP, what is subnet mask, how to configure the IP on the interface. These all things you must already know. So I went on the interface 0 by 0. I did the no shut on that interface, and I configured the IP address on this interface. Now, what happens when we configure the IP address on the interface? This router, when it tries to configure the IP on that interface, first of all, this router will try to find out if this IP that we are trying to configure, that the IP address that we are trying to configure on that interface, if this IP is unique or not. In this broadcast domain, in this network, the IP that I am trying to configure here, is this IP unique or not? The first thing that will happen when we configure the IP address on the interface, not only on the router but on the PCs as well, they try to find out if the IP address that we are trying to configure, is this IP unique or not. If the IP is unique, then the IP can be configured on the interface. But if the IP is not unique, then of course that IP cannot be configured on the interface.
Sorry to interrupt. How it's going to identify if it is unique IP address?
Yeah, that's what we are going to discuss. We will talk about it. So that's what we are trying to find out, how it is going to discover it. So if the router 1 finds out that this IP is unique, then it's okay. It will configure it. And if the router finds out that the same IP is also configured on some other machine, other PC or whatever, then of course the router will show you some messages saying that the same IP is also configured on some other devices and all. IP duplicacy, IP duplicate IP addresses, or duplicate IP address message, you will see if the same IP is configured somewhere. So how this router is going to find that out? Before it configures the IP on the interface, before it configures the IP on this interface, the router is going to generate an ARP message. Generally, we know that ARP, address resolution protocol. It is like when we have the IP address and we want to know the MAC address, then in order to resolve the MAC address from the IP address, we use the ARP. That is one of the use case of the ARP. But here, like when we talk about like the IP duplicacy, when we talk about like when the machine tries to find out if the IP address is unique or not, there also a concept of ARP is basically used. Before this machine, before this router configures the IP, that IP on the interface, the machine, the router basically is going to generate an ARP message, and it is going to send that ARP message in this particular broadcast domain. That ARP message is not to actually, that ARP message, that ARP message is actually not to get the MAC address from any IP address. Rather than it's more like announcing. It is more like to announce, it is more like to tell everyone that I have this particular IP address and its associated MAC address is basically this one, AA, BB, CC, 00 and 1000. So as soon as you hit enter, you can see right here in the capture, right here you can see here you have an ARP. Here we have an ARP right here. Here we have an ARP message for 192.168.1.1. Where is that? So here is an ARP. Here the router 100% AA, BB, CC, 00, 1000. So here basically the device has sent. Here the device has basically sent an ARP message. If you open this ARP message, in that ARP message, this is the format of the ARP packet. So address resolution protocol, a hardware type Ethernet protocol IPv4. Then we have sender MAC address, sender IP address, sender MAC address, sender IP address. Oh, by the way, we did not configure the MAC address anyway. Okay. So sender IP address, sender MAC address, then target IP address and target MAC address. As you can see, this ARP message is different from the traditional ARP, from the regular ARP message, because in the regular ARP message, when the machine sends an ARP request, in that regular ARP message, the target IP is the IP address of the machine whose MAC address we are trying to find out. But here that's not the case. The objective of this ARP is not to find out the MAC address from the IP address, rather than it is to announce that I have this IP and this MAC address. It is rather to announce that I have this IP address and this MAC address. This type of ARP that you see right here, it's called gratuitous ARP. Gratuitous ARP, this is gratuitous ARP, this GARP, we call that GARP, G-A-R-P. It is ARP reply. It's not, by the way, ARP request. It is ARP reply. It is ARP reply, but it is different from ARP reply. In ARP reply, we get like here is my IP, here is my MAC address. But in this gratuitous ARP request, in this gratuitous ARP, basically the machine is announcing its IP and its respective MAC address to everyone, and of course, it is being, you can see, broadcasted. It is being broadcasted. You can see that ARP packet is getting encapsulated via the data link layer header. Address resolution protocol, ARP messages, they get encapsulated via the data link layer. At the data link layer, we have the Ethernet header. In the Ethernet header, we have the source MAC address, we have the destination MAC address. You can take a look at the destination MAC address. It's a broadcast MAC address, which means that this packet will be delivered to everyone in that particular broadcast domain. And type ARP, what is being encapsulated? ARP is being encapsulated. So ARP has the type of 0x0806. It sends this gratuitous ARP message and it waits for the reply. It sends the gratuitous ARP message and it waits for the reply. Once the ARP times out, once it does not get any conflict message. If, let's say, for example, some other machine also has the same IP and MAC address, if the other machine has the same IP address and MAC address, when that machine receives that GARP message, when that machine receives that gratuitous ARP message, the machine will say, I also have the same IP and MAC address. So IP duplicacy. This is the IP that you are trying to configure is actually a duplicate IP. You can see. But fortunately, we did not get any reply. We did not get like any response as when we sent this gratuitous ARP, when we sent this GARP message, we did not get any responses, meaning to say that it is safe to configure that IP address on the interface, because that IP is in fact unique, because no one else has sent me any message saying that I have the same IP address and MAC address configured on my interface. All the machines do that. Later on, if you plan to, and since everything was okay, that's why show IP interface brief, fast Ethernet 0x0. You can see since everything was okay, that's why you are able to configure. That is why you are able to configure that IP address without any errors, without any problem, without any messages saying that the same IP is also configured somewhere else. No problems, no issues. The IP was successfully configured on the interface. If you, by the way, configure terminal, interface is 0x0, and if you try to change your MAC address, let's say, for example, I have changed my MAC address. If you change your MAC address to AA, as per the topology, AA, BB, CC, 00, and 1001. Let's say, for example, you change your MAC address. When you change your MAC address, at the very end, when you change your MAC address, it will again send the gratuitous ARP message. It will again inform everyone that hey, I have changed my MAC address. It will again inform everyone. You can see right here, when we changed our MAC address. For example, I went on that particular interface and I changed my MAC address to AA, BB, CC, 00, 1001. As soon as I change it, the machine again sends the gratuitous ARP message saying that I already have configured, saying that I have configured this IP along with this MAC address, and if anyone has the same IP and MAC address, let me know. Again, fortunately, like we did not get any reply, we did not get like any responses. So meaning to say that this IP and MAC address settings were okay. The only place where we have configured this IP and MAC address is in fact that interface Ethernet 0x0. So not a problem, no problem. So I was able to change my MAC address without any problems as well.
Sir, actually, we were able to see something duplicate over there, right? Inside the packet, when you opened it, there was a yellow line like duplicate IP address detected.
Yeah, because that is on the same interface. If you expand it, like, this is like also in use by AA, BB, CC, 00, 1000, which is the MAC address of the same interface. So like the earlier MAC address was 1000, now we have changed to 1000. But this is not a reply actually. This is nothing. It is just basically another way of saying that the particular IP and MAC address setting is used by the interface 0x0.
Okay, thank you.
It is basically the same interface where we had the IP and MAC address earlier as 1000. Now we have changed it to 1001. So nothing like it's not a problem.
Okay.
Now you do the same. Okay, you do one thing. You go on the host one, and on the host machine one, I will go to the host machine one, and here it is also, by the way, a router. It is possible to change the IP and MAC addresses on the router, no problems at all. So here I'm going to configure this router as a PC. I'm going to enable, I'm going to say configure terminal host name host 1, and I'm going to say no IP routing. Routing is disabled. So it's just the end user. I have disabled the routing capabilities of that machine to make it act as just a simple PC. And then interface is 0x0. I will do the no shut on that interface. And if I try to configure the same IP address that I have configured on the router 10x0, see what happens. IP address 192.168.1.1 255.255.255.0. As soon as I hit enter, you immediately got the message. Why? Because now when you configure the IP address, as soon as the neighboring machine sends a gratuitous ARP message saying that I have this IP and I have this particular MAC address, I have this IP and I have this MAC address, immediately you will get the message from the neighboring device saying that I also have the same MAC, I also have the same IP. So IP duplicacy. It will generate these kind of logs saying that the IP duplicacy, duplicate IP addresses, duplicate address has been detected by this particular. Why you get this message? Because whenever we configure the IP address on the machine, machines try to find out if the IP address is unique or not. If the IP address is unique, they will be able to configure that IP on the interface without any problem. But if the IP address is not unique, if we have configured the same IP address on multiple devices, you will get this kind of message on both the devices saying that the same IP is also configured on somewhere else. So I will, of course, go to the host machine. I will either correct the IP here or there. So of course I need to correct the IP here. It is going to be 1.2, and just for the now, when it sends the GARP message, it will not get any reply or anything. So it will consider that the IP is actually unique, and it will be able to configure that IP on the interface without any problem. Also, just for the sake of our topology, I will also change the MAC address of that interface so that it becomes easy for us to understand the packet forwarding process.
Hello, Surinder.
Yes.
Yeah, this GARP message is sent only one time.
Whenever you configure the IP, every time, or whenever you change the MAC address, every time. Okay, fine. So we have configured, by the way, we have configured the IP address and the MAC address. We have configured the IP and the MAC address on the interface, and we have configured, by the way, do show run interface ETH0/0. We have configured the IP and MAC address on the interface. By the way, about the Wireshark, anything that you see in the Wireshark capture, anything that you see in this big bracket, it's not present in real time. It's just in the Wireshark only. Anything that you see in this big bracket, anything, this one or maybe this one, anything that you see in this bracket, it's not actually in the real packet. It is just in Wireshark. So this is not even there actually. This is the first thing that will happen when we configure the IP on the interface. On the router,
yeah. So the MAC address is actually the physical address, right? It's hard coded on the NIC level, right?
Correct.
So if we try to change it or manipulate it, that is the logical address, right? Like a similar to IP address.
Yes, but yeah, that is fine. But modern day devices, they give us the ability to change the MAC addresses as per the requirement. So I can go on the router, I can go on the PCs, and I can change the MAC address to a random value. In fact, nowadays the modern day laptops, the mobile devices, or all these devices, they follow this concept called randomized MAC address. So all these devices, they will have a built-in, they will have a burn-in MAC address. That is fine. But whenever we want to connect our devices to the network, they will choose a random MAC address. So it is fine that we have studied so far that MAC address is hard coded, burn-in address, XYZ, whatever. But it is possible to change the MAC address as per our requirement.
Okay, thank you.
And will it wipe out the burnt-in MAC address?
No, it will not.
So it will stay.
Yes, you can confirm it by the command show interfaces Ethernet 0/0. You can use the command show interfaces Ethernet 0/0, and you can see what is your burn-in address, BIA, and you can see what is the MAC address that you have configured. So if you have not configured it, then the same will be used. But since we have configured some different MAC address, so this will be used for the communication and this will not be used for the randomized MAC addresses. Have the advantages that they prevent MAC address based attacks in the network, especially when we are connected to a public network such as public Wi-Fi's and all that. It makes harder for the attackers to discover the devices because the MAC address is completely random. But also the randomized MAC address concept also adds a few issues. If two devices are using the randomized MAC addresses, there are very good chances that both the devices might accidentally select the same random MAC address. So I hope you already know that MAC addresses cannot be same between the two devices. MAC addresses have to be different. So that will also add some problem, but it is completely possible to change the MAC addresses.
And setting up the values for randomized MAC address, is there a set of values that we have to choose, or
no, automatically? So this is the first thing that will happen. This is the first thing that will happen when we configure the IP address on the router interface. The second thing that will happen is as soon as we configure the IP address on the interface, immediately, whatever IP and mask we have configured, whatever IP address and mask that we have configured, right away, the router will calculate the network ID from that IP address and mask, and it will install that network ID in a table called routing table, which you also call a route. When we configure the IP address and subnet mask on the router interface, router is now aware that 192.168.1 network IP is connected on the interface 0 by 0. The router 1 becomes aware that network 192.168.1 is connected on the interface 0 by 0. In order to memorize, in order to keep that information, in order to maintain that information, in order to remember that 192.168.1's network is connected on the interface 0 by 0, the router will add the entry in a table called show IP route. You can see that the entry got added in a table called routing table that you can validate by the command show IP route. And you can see C stands for connected. It is there to represent the directly connected routes. So 192.168.1.0 is directly connected on the interface 0 by 0. And L means local. Local means what IP we have configured onto that interface. So on that interface, we have configured the IP address 192. Whatever IP we configure on that interface, whatever IP we configure on the interface, it is represented as an L entry. L stands for local. L stands for local. A local entry. That means like this particular IP is configured on the interface 0 by 0. We have not configured the mask, by the way, /32, so don't get confused. The interface Ethernet 0 by 0 is configured with the IP address 192.168.1.1/24. That's how they nowadays, that's how the modern day routers, they show the entries present in the routing table. Earlier, we don't used to have this L entry in older versions of the operating systems, such as iOS 12, 12.4, 12, like old versions. We don't have this L entry, but in the new iOS versions, you also have this L entry, which is to let you know what exact IP we have configured on that particular interface.
One quick question. Yes, sorry to interrupt. So I checked in this this L entry. So is it only for Cisco Catalyst devices, or it's for
Yes, mostly in the iOS you will see this. Other vendors, they might choose or might not choose to implement this, but in Cisco iOS, latest iOS versions, you will see this L.
Yeah, after attending yesterday's class, I checked in Nexus. There is no L entry.
Correct. So they choose to like implement or not implement this S entry, but in the iOS XE based devices, you will find the L. This is the second thing that will happen. As soon as we configure the IP address on the router interface, router becomes aware of the particular network connected on that particular interface. It maintains that information in a table, which is what we refer to as the routing table. That's why, if you remember, we used to say that routers, they maintain the directly connected network information in the routing table. Why? Because we have configured it. Because we went on the interface 0 by 0, we did the no-shut on that interface, we configured the IP address on that interface. As soon as we configure the IP on that interface, a router becomes aware of the network, maintains that information in the routing table. So that whenever the router receives a packet for any IP belonging to 192.168.1, the router is able to forward that packet out of the appropriate exit interface. Which brings me to a question now. The concept of ARP that we have studied so far, the GARP, ARP, GARP, whatever, it is valid only and only on the Ethernet technology. ARP is there to resolve MAC address from the IP address. Concept of MAC address is only valid on the Ethernet interfaces. There is no MAC address on the serial interface. On the serial interfaces, we don't have the MAC addresses. Although we don't see the serial interfaces that often nowadays, but show interfaces serial 1 by 1. You can see that on the serial interfaces, show interfaces serial 1 by 1. You can see that you do not have any such concept of MAC address. The concept of MAC address is only there on the Ethernet technology, not on the serial technology. And the reason is simple. We have these devices called Ethernet switches. Using the Ethernet switches, what we can do, we can connect multiple like PCs, devices. We can build basically a point to multi-point network. We can build something called a multi-access network. To be more precise, we can build something called a multi-access network. Multi-access basically means that a network where multiple devices are accessing that network at the same. In the multi-access technology, since Ethernet is a multi-access technology, in case of Ethernet, when the data needs to be sent from the device A to the device B, some sort of unique addressing has to be there. Some sort of unique addressing has to be there. that these two devices must be uniquely identified. These two devices must be uniquely identified in this Ethernet technology because there are other devices also connected on the same interface, same switch actually. Serial technology, however, when we connect two or more devices via the serial technology, we can't even connect it like that. There's no such thing like that. We can't even connect it like that. These switches are called Ethernet switches for a reason because we use the Ethernet technology to connect multiple devices together. These are not called serial switches. So Ethernet technology is a multi-access technology, but the serial technology is actually a point-to-point technology. It's obvious that if you send the data from here, the only place that the data will get delivered is the neighboring device. The data cannot go to any other devices because actually there is no other devices. So here we don't need to uniquely identify the sender and receiver because it's obvious that if the data leaves this interface, the only place that the data will get delivered is this one. In the serial technology, that's the reason we do not have any concept of MAC address. No MAC address. MAC addresses are there to uniquely identify the devices at the data link layer, especially beneficial when it comes to multi-access technology. But when it comes to like serial technology, it's a point-to-point technology. In the point-to-point technology, we do not actually need to uniquely identify the sender and receiver. That's why in the serial technology, we don't have the MAC address. We used to have the switches. We used to have the switches called, frame relay switches. We used to have the switches called frame relay switches where we used to have multiple serial interfaces. So in earlier days, it was possible to build this kind of topology. It was possible because we used to have this technology called frame relay switches. We had ATM switches. We had X.25. We had different types of technology. But here still, we don't used to have the MAC addresses. The unique identification of the sender and receiver was not done based on the MAC address. Even in this case, we used to have this a concept called DLCI, data link connection identifier, DLCI, LMI, and we had different concepts regarding that. But still, the MAC address concept was not there. You don't see the serial technology very often nowadays. Like in the serial technology, you don't get like a lot of bandwidth, a lot of speed and all. So nowadays, like Ethernet is more popular technology for the LAN, in fact, as the WAN environment as well. So nowadays, Ethernet has become like more popular technology for LAN and WAN both. So serial technology is not that much commonly used in a modern day network. When the data has to be sent out of the Ethernet interface, the protocol that is responsible to encapsulate the data, when the data is sent out of the Ethernet interface is called ARPA. Encapsulation, ARPA, Advanced Research and Project Agency. Ethernet header, Ethernet trailer, basically when the data exits out of the Ethernet interface, the Ethernet header and Ethernet trailer is basically added. ARPA is the protocol responsible to add the Ethernet header and Ethernet trailer for the data that is sent out of the particular Ethernet. But on the serial, that's not the case. On the serial technology, we used to have the protocols such as HDLC. We used to have the protocol called Triple P. We used to use the protocol called frame relay. We had multiple protocols of choice that we wanted to use when the data exits out of the serial interface.